Hi, this is Ms. McLean, and this is a 6.1 homework question. So this is the gist of the problem. We are asked to find the two values where 60% of our data is in the middle. We are given a mean and a standard deviation. So I'm going to go ahead and draw a picture so you can see what this problem is talking about. So here's our normal curve, and 60% of data is in the middle. And we are asked to find the two values. Okay, so we're trying to find the data items. So with that being said, I'm going to go to my formula sheet, right? So chapter 6. For the normal distribution, if we are trying to find the raw scores, which is the data items or the values, that formula is x equals mu plus z times sigma. So I'm going to jot that down off on the side. And so right now we know what mu is, we know what sigma is, but we have two unknowns. And of course, ultimately we're solving for x. And so we need to find out what the z-scores are for these values. So to figure out the z-scores, we're actually going to go backwards. We cannot plug into the z-score formula because, again, we don't know what x is, okay? So we're going backwards to where now we know the area under the curve, but we don't know what the z-score is that belongs to it. And so we are going to use our table 8.2, the cumulative normal distribution, in order to help us figure that out, okay? So as a reminder, all of these values in the middle belong to the areas that's under the curve. So we're going to search inside the middle of the table, and from here we're going to grab the z-score, and once we know our z-score, we can plug it in and get our x, okay? So that's where we're headed. Now, I don't know the area that belongs to x2 or x1 because all I have right now is what's in the middle, which is 60%, okay? Recall that the entire normal curve is equal to 1, or in this case, when it's percent, 100%. So if I take away the middle, then that leaves me with 40%. Now, normal distributions are all symmetric, meaning if I chop this in half, I can fold it over and they're equal to each other. All right. So what that means is this 40% on the outside is split in half. So if I divide by 2, then I get 20%. So that means each side is 20%. Now, that's good news because now if I look at the area from x1 to the left, it is 20%. Okay, so I'm going to jot this down underneath. This is 20%, or of course we can change it to 0.20. That is the area. So from here, I can figure out a z-score, right? So I'm going to do that in a minute, right? So I'm going to do x1 and x2 at the same time. So now let's talk about x2. x2 starts here at this line and it goes all the way to the left. So what happens? I have 60% plus this area here, which is 20%. So 60% plus 20% gives me 80%. So the area that we're going to be looking at is 0.80. Okay, so that's 80%. All right, so now that I have the areas, now we can search for our z-scores. So again, we want to go in the middle of our table, okay? Now, the positive z-scores are for areas for the right side, so 0.5 on out. So I'm going to go to the negative z-scores, and we want to look for 0.20. So 0.20. So I know this is super tiny, right? So just kind of bear with me. So 0.2 looks like right around here in the middle. Okay, so we have 0.2005 and 0.1977. So this is like 23 away. We don't want that one versus 5 away. Okay, so this is the one we want. That is negative 0.84. Okay, so negative 0.84. Now, the cool thing about these is that they are always opposite z-scores. Okay, remember this is chopped in half. See the 20 and 20? So that means they're falling opposite of each other, one negative, one positive. Now you can look up the other one if you wish, and you're going to see we're going to wind up getting the same thing. So we're looking for 0.80, so as close as we can get. So it looks like right here, we are 5 away. What is that, like 5 10,000ths away? So that is 0.84. See, there it is. So 0.84. So now that we have our z-scores, now we can plug it into our formula. Mu is 75. Z is negative 0.84. Sigma is 6. So let's find the first data item. So I'm just going to plug it in. So that's given us 69.96. And of course, I'm not sure how we're supposed to round for this problem. I don't have those specifics. So if it's asking around to the nearest whole number, it would be 70, right? And then I am just going to press up and I'm going to erase my negative. See, so it's going to be a positive z now. So there's 75 plus 0.84 times 6, and that gives us 80.4. So here are our two values for x1 and x2. A good little quick check if you're like, man, I'm not sure if this is correct. Look, 69.96 is to the left of our mean. Our mean is right down the middle, 75, and look on the right side, 80.04. So that's a good sign if we're getting a value to the left of the mean and to the right of the mean, okay? All right, so that's how you find two values when you're given the percentage of data between the two values.